Hi, I'm John, and this is my video about Microsoft AI services. So in this video, I'm going to be talking about Microsoft's suite of AI services, specifically AI services available on Microsoft Azure. And I'm going to be looking through some of the model types that are available, the different areas of AI available on Azure, and then diving into some of the specific AI services and what they do and what they can provide. So first of all, I just want to do a quick overview of artificial intelligence and what it is in the context of Azure and more generally. So artificial intelligence is the ability of computers to perform tasks typically characteristic of humans. And computers learn from massive amounts of data and interact and respond more naturally. So where we look at more traditional computers that carry out operations or calculations, artificial intelligence can do more capabilities more characteristic of humans, like recognizing things in images, recognizing the meaning of text. And it does this by being trained on large data sets and being able to recognize patterns in those data sets. So some examples of the capabilities of AI are seeing or understanding videos and pictures, listening, translating or transcribing or interpreting written or spoken language, carrying out dialogue through chat and speech, known as conversational AI, reasoning by understanding relationships between people, things, places and events, and automatically detecting unusual activities in the system. So a lot of these capabilities, whilst some of these could be done with more traditional computers, they would require a lot of programming, a lot of algorithms, complex algorithms, and these algorithms wouldn't necessarily take into account every situation or more unique circumstances, whereas artificial intelligence can cater a lot more to these situations. So now diving into Microsoft AI services. So Microsoft has a heavy focus on AI in all different areas, including Azure, Microsoft 365, and other services such as Power Apps. So this presentation is focused on the Azure services that are available in Microsoft Azure. And as with many other Azure services, we can deploy these services, and we typically have more control and access to them when compared to Microsoft 365 services, for example. And there are a portfolio of AI services for developers and data scientists. So this is a key benefit of AI services on Azure. When we traditionally think of AI services, it's quite common to think that AI is an area just for data scientists. Due to the complexity of the technology and the underlying science of the technology, it can be easy to think that AI is a very specialized field. But Microsoft AI services actually allow typical developers to access AI technology through things such as API calls and connectivity to Azure to reduce the technical burden involved in adopting AI in our applications. And this is a benefit of Azure AI services, that more typical developers can consume these services. These services cover areas such as vision, language, speech, decision making via an API call. It's targeted at various skill levels, as I mentioned. It enables AI to be integrated within applications. So if we're developing an application in our chosen framework or programming language, we can consume these AI services as required for the purpose that we need. And many of these services allow us to build custom models with our own data and without machine learning experience. Models can be deployed to containers, and since these are services available on Azure, they're typically seamlessly integrated with the Azure ecosystem. So other services that we have on Azure that may not necessarily be AI services A lot of the AI services follow the same rules. Do we need the ability to integrate with our local network, as an example, and all of those standards that we typically see around Azure services? So the first AI service I want to cover is Azure AI Studio, and this is a recent new product provided by Microsoft, and it's been built as a central place to manage AI services in Azure. It's a development hub for building, testing, deploying, and managing generative AI applications, and it offers a variety of features to developers of all skill levels, and it aims to democratize AI development with a focus on enterprise-grade security, compliance, and responsible AI practices. So this Azure AI Studio has been driven by the recent developments and appetite by many organizations to adopt AI, thanks to the popularity of large language models and generative AI over the last 12 months. And the key features of Azure AI Studio is it facilitates direct interaction with project code through Azure AI SDK and Azure AI CLI, and it promotes a code-first approach. So SDKs, Azure CLI, these are common, widely used tools across all of the Azure stack, and this provides a familiar experience to developers also. Finally, it's designed to be a collaborative environment by providing a shared environment where developers can work together, sharing files and connections to pre-trained data and compute resources. Cool. So the next service to discuss is Azure Speech Service, and this is one of the catalogue of AI services available on Azure. So Azure Speech Service provides an API that provides speech capabilities. So if we're looking to integrate with our application, we can use Azure Speech Service via the API to enable speech to text or text to speech. There's a range of voice types, styles, and other options available, and it enables us to build custom and unique voices. So whilst Azure Speech Service provides various different voice types, styles, so we can use different emotions, anger, happiness, or others, we can also build our own custom voices, so feed in our own data to maybe create a voice that's unique to our brand or our organization. So then we have speech to text. So this is whereby we can send a speech audio recording to Azure Speech Service, and Azure Speech Service will give us a response telling us what was said in that speech in plain text. And it enables us to transcribe the speech into text in real time. Extensive support for multiple languages and dialects. Custom models to understand domain-specific terminology, jargon, or accents. So if we're within an organisation, we've got different terms that are used that are not commonly used more widely, we can train our models to recognise this language. Advanced algorithms that can filter out background noise and adapt to different acoustic environments. And this calls out one of the benefits of AI again as well. Something that's harder to do with more traditional computers is when we've got recording and a lot of background noise, being able to distinguish the background noise from the voice, which a human can do quite easily. A traditional computer can have a hard time, and background noise can interfere heavily with transcribing, whereas AI, based on its training, can more easily differentiate between the background noise and the voice that it's trying to capture. So then we have text to speech, and that is in the opposite direction. So we can make an API call to Azure Speech Service with text, and it will return a voice generated speaking the words of what was in that text. And it enables us to generate natural sounding speech, closely mimicking human voices and intonations. So this again highlights another benefit of AI and where AI is better at this than a more traditional computer. If you're familiar with ringing up phone lines and you've got an automated voice and it may sound very robotic if it reads numbers, the inflection of the words doesn't sound right, you can tell it's a computer. Whereas with AI, it sounds a lot more natural, a lot more like a person speaking. It's not necessarily 100%, it doesn't necessarily sound like a person, but it does sound a lot better than more traditional computer generated speech. So then, as mentioned, we've got a wide select of predefined voices. So voice customization, we're drilling more deeply into that. So we can create custom voices that represent a brand or a character uniquely. Support for different speaking styles, emotions, enabling more engaging and context-appropriate audio content. Fine-grained control over pronunciation, pitch, rate, and volume. So you can, in the Azure portal, through Azure AI Studio, we can test out these voices. We can play around with pronunciation, pitch, rate, and volume until we've got the perfect voice, and then we can put it into our API called the pitch and the rate and the volume that we want. So typical use cases for Azure Speech Service is making content accessible to people with disabilities by converting text to speech and speech to text, powering interactive voice response systems for more efficient customer service, language learning and providing reading aids with text-to-speech functionalities, generating voiceovers for video presentations or digital assistants with customizable voice options. So the next service I want to talk about is Azure Machine Learning, and this is one of the more traditional AI services available on Azure. It's a service for building, training and managing machine learning models at scale. And a machine learning model is an artifact that is produced by training a machine learning algorithm on data. A trained model can make predictions or decisions without explicitly being programmed to perform the task. So what we can do with Azure Machine Learning, if we take it, for example, house prices, if we have a lot of data on information about sold houses, how many windows, the characteristics of the house, a semi-detached, a detached, and other characteristics about the houses, if we can feed that into Azure Machine Learning and train the model, once it's done with its training, and then later we have a new house and we ask the machine learning model, based on its training, based on the data it's been trained on, what might be the value of this house or what might it sell for, it can make a prediction even though it's not seeing the complete unique characteristics of that house. So this is one of the benefits of Azure Machine Learning. If we were to do that with more traditional programming, we may not be able to cater for every scenario, or far fewer scenarios at least, and we might need to write explicit code for each scenario. Whereas Azure Machine Learning, it can make predictions based on the data that it's been trained on. So Azure Machine Learning allows us to create reproducible workflows for building, training and deploying models with ML pipelines, and incorporate Azure DevOps or ML Ops practices. Typical use cases may be predictive maintenance, predicting machinery or equipment failure. So based on the data, that's another good example is if we have equipment within a factory or a manufacturing industry, and we collect a lot of data on our machinery, and we have data about the machinery before it fails, then Azure Machine Learning can look at data of other machinery, and it can find consistencies and potentially predict when that machinery is going to fail in future as well. Financial fraud protection, so looking at the data of a transaction based on what it knows is typically fraud, it can make a prediction about transactions. real estate price prediction, which was one of the examples that I gave earlier. So let's look now at a real world example of how we might use Azure Machine Learning. So we've got a telecoms company which would like to predict which customers are likely to leave the service in the near future. The company would like to identify these customers so that it can take proactive steps to retain them. So this is going to run through a kind of high level process of how that organisation, telecoms company, may tackle that problem using Azure Machine Learning. And step one is to aggregate data from various sources: customer profiles, usage data, billing history, customer service interactions, and social media activity. So the more data that we can get, the better, and the more accurate that the Azure Machine Learning model is likely to be. We cleanse and pre-process that data to handle missing values, correct errors, and standardized formats. Features are engineered to capture relevant patterns in the data, such as usage trend, billing anomalies, and frequency of service issues. We use Azure ML's AutoML to experiment with different algorithms and configurations to find the best model. Common algorithms for this include churn prediction. For churn prediction include decision trees, logistic regression, and gradient boosting machines. We split the data into training and validation sets, train multiple people on the multiple models on the training set whilst evaluating their performance on the validation set. Metrics may include accuracy, precision, recall, and area under the curve. And finally, we select a model that performs the best on the validation set. So step two is all about preparing the model, finding the correct model, finding the best model based on the training. Then we have model evaluation and validation. So further evaluation on the selected model on a separate test data set. So data that it's not seen before. We can feed that data in. How does it do? Is it correct in its predictions in the model that we trained earlier? Assess the model's generalization capability and perform additional validation techniques such as cross-validation to ensure readability and robustness. We then have model deployment. So once we have validated all of that and our model is prepared, we can deploy the trained model using Azure Machine Learning's deployment capabilities, and we can access that model via a REST API. So this is when we start integrating into our application and we want to consume that model. That's what we can do at this point. Then for step 5, we've got model monitoring and management. So continuously monitor the model's performance to detect any degradation over time due to the change in customer behavior. So when we train the Azure Machine Learning model, that should be valid at that time, but over time customer behavior is going to change and the model is going to become less relevant, and that's when we then need to start retraining our model and repeating this process. So it's a continuous improvement process. Track usage, performance, and set up alerts for potential issues. Step 6, we've got feedback loop and continuous improvement. So collect feedback from the deployed model's predictions and the actual outcomes to analyze discrepancies, understand the model's performance in the real world, retrain the model with new data to ensure it remains relevant and accurate over time. Finally, when we've adopted Azure Machine Learning, we can tackle the original issue, which was to identify at-risk customers. So based on our training, the Azure Machine Learning model's training, we should be able to make predictions of when customers are going to leave, and at this point identifying at-risk customers. Implementing target retention strategies such as personalised offers, improved service plans, or direct outreach. So potentially this can be completely automated end to end. In the data we can see that this is an at-risk customer. We can give them a personalised offer, an improved service plan, or offer them something that's better to their needs and potentially proactively stop that customer from leaving. So the next service is Azure AI Search, and this provides secure information retrieval at scale over user-owned content in traditional and conversation search applications. So information retrieval is foundational to any app that surfaces text or vectors. Capabilities include a search engine for vector search and full search and hybrid search over a search index. A typical use case for Azure AI Search may be catalog or document search, data exploration, or increasingly chat-style Copilot applications over proprietary grounding data. The next service we have is Azure AI Video Indexer, and this uses machine learning algorithms to extract insights from videos. Developers and organizations can gain actionable information without manual annotation or metadata. Capabilities include transcription, face detection, speaker identification, sentiment analytics, and language detection. A typical use case may be transcribing lectures for topics discussed, tag content, or translation for international students. So then finally, we have the Azure OpenAI service. So if you're familiar with ChatGPT, ChatGPT and OpenAI provide a REST API that allows you to connect to ChatGPT and provide response and obtain answers to queries as you would using ChatGPT through a browser. And Azure OpenAI service is effectively this available on Microsoft Azure. So the difference between Azure OpenAI service and OpenAI's API directly is Azure OpenAI service provides many of the enterprise-grade features of Azure services that we're used to. So things such as enterprise networking, we can connect to Azure OpenAI service to our internal network, and our application can consume it over our LAN, which isn't available with OpenAI directly. Regional targeting as well, so we can choose that we want Azure OpenAI service to deploy to a certain region or continent, which may be a need for data sovereignty requirements and security requirements. Simple adaptation to your specific task. So the same as with ChatGPT, when we can quite easily adapt the response that we can receive. We can choose how we want it to be formatted, what information to contain, or how detailed or undetailed we want it to be, high level, low level, etc. The options are limitless, and that's how Azure OpenAI service works also. We can simply adapt the model's response in natural language, in plain English, to the model. And the cost of Azure OpenAI service is determined using tokens, and tokens are essentially the length of the text in our API call and the response. So this is around, I think, about 4 cents. Well, we have actually this diagram here. We can see for GPT 3.5 per 1,000 tokens, which is approximately 250 characters, though it may vary. That is 0.15 cents for GPT 3.5 Turbo. So the length of the request, the more data that we feed into our API call, and the more data we want to send with our API request, the higher the cost will be. And the response also, the length of the response from the AI model will also add up as tokens that we get charged for. So there's no standing cost for Azure OpenAI service. A lot of Azure services, you deploy them and they've got a fixed cost of, say, example, $500 a month for a large VM. This isn't the case with Azure OpenAI service. It's based on how much we consume, how big our API calls and responses are from Azure OpenAI service. We then have the capability of fine-tuning, so we can feed in our custom data into Azure OpenAI service to get a more relevant and correct response. And this is just one of the methods available for getting a better response from Azure OpenAI service. Fine-tuning can be quite costly, but it's known to provide very good training, very good model responses. So fine-tuning refers to the process of retraining pre-trained models on specific data sets. It's typically used to improve model performance on specific tasks or introduce new information that wasn't well presented in the original training. The reasons that you might fine-tune is to steer the model to output content in a specific or customized style, tone, or format. The information needed to steer the model is too long or complex to fit into a prompt window. So as I mentioned, tokens are the way that we are charged for using Azure OpenAI service. So you can imagine if we're trying to get a better and better response from Azure OpenAI service, we may be tempted to put quite a large amount of data in the API call, but that's going to increase costs. So fine-tuning, if we know that we're going to have to often put a large amount of data into our API call, we may choose to instead fine-tune the model so that we can make our API calls smaller because the model has already been trained and we don't need to contain that data every time. But this should be caveated that there's a significant upfront cost to fine-tuning. So we need to balance out the cost of fine-tuning versus containing the data in the API call. So reasons we may not fine-tune are no clear use case for fine-tuning. So this means that we shouldn't fine-tune because we think that that's probably the thing we should do. We need to have a good use case for fine-tuning. And large upfront costs, though ongoing costs may be reduced due to the smaller prompts. That concludes my presentation on Microsoft AI services. Thank you for watching.